Hey guys, how's it going? So today I want to touch base on one of the new models that just got released, which is called GLM 5.2. There has been actually a couple of releases this month that I find quite interesting and really good for open weight models. Obviously, everyone knows that we had one of the biggest models coming out from Anthropic as well, which is called a Mythos style family model, Fable 5. I did get a chance to use it a bit, and I did build quite a bit of stuff with it just before it was taken down. So really what I want to do today is just walk you guys through some of the tests I did with Fable 5 and GLM 5.2. I also have to preface that I ran Kimi K2.7 and Minimax M3 all local. So I'm running GLM 5.2 at Q4, Kimi K2.7 Code at Q3 KXL, and Minimax at Q8. Also, I have an IQ4 version of Minimax M3. So these are all from the local tests. The only tests that I'm doing that are not local are the Anthropic Mythos ones. And here you can see, switching back to GLM 5.2, and why it's so good is it is kind of a step up for open weight models right now. We have a benchmark against the best models, Claude Opus 4.8, in a lot of tasks, and it's coming in not far behind. I did get to use it just a bit locally, and it is quite fantastic actually. It is actually a step change above what we've been using earlier. Now, if you look at some of the benchmarks, obviously this is like maybe benchmark maxing or whatever, which is what they say, but just from the feel of it and having it run locally here, I did get a sense of how to compare it against Kimi K2.7 as well as Minimax M3, which are one of the best open weight models, and also the Mythos style models. Now, I do use GPT 5.5 codecs, and I use the Anthropic OpenAI Claude Code, and I've used basically all of them simultaneously at one point during the last couple of weeks, so to get a good impression of what's happening and how it is changing. Okay, get ready for a flashbang. Unfortunately, I don't have a way to make this artificial analysis dark mode. Okay, here we go. We're at artificial analysis. I just want to touch base that this is the score currently for a GLM 5.2 max, which is the 51. There are two settings. There's the max setting for GLM 51, or sorry, GLM 5.2, and there is a high setting. So this is the max setting. And as you can see, we also have released Minimax M3, which is at 44 now, and these are the new 4.1 index scores, so you'll see them a bit lower than you remember. We also have Kimi K2.6 at 43 now instead of like 50 something with the new benchmarks, and also I believe Kimi K2.7 is around here. I'm just going to try to include it. Kimi K2.7, I believe it is a bit lower on the index than Kimi K2.6 because it's strictly for coding rather than for everything. So you will have to take that with a bit of a grain of salt, that this is a benchmark that includes everything rather than just coding. So as you can see, that GLM 5.2 is actually on par with GPT 5.5, 5.4x high, and based on the recent, just benchmarked on front-end design, it is really good. Now, Claude Fable 5, which is not available, is at 60, and at that point I felt like it could actually do things that the prior models could not, like one-shot pretty complex things as well as 3D games. Now, obviously this is just a benchmark suite, and take all of it with a grain of salt. Let me show you another graph here. Okay, just quickly touching base on why these models are a pretty big deal. As you can see, Fable at 59.9 here on the chart. This chart has been taken from artificial analysis, and I just put a bunch of formulas and R squared and make sure that these lines represent some of the scores that are coming out. We have the closed source models, which are pretty good regression here. It is still on the trend line. As you can see, Fable is at approximately the same spot that we're expecting it to be. And you can see a projection into the future, what we will have in Q4 and 2027 Q1. Now, the thing about the open large weight models, these are 500 billion and below, 500 billion and above open weight models. And the reason I did that is because I want to check basically the DeepSeeks and any very large ones that are like the 1 trillion parameters or GLMs, and to see where they are in this kind of trend line. You can see that they are in about this trend line where we have the new triangles, which are the new GLM 5 and 5.1, 5.2 scores. We also have the open small weight models. They're all basically parallel to each other. You can also see that with the regression line for the GLM new family of 5 models, the 744 billion parameters, something like that. They're on a bit of a steeper curve because there's only 3 data points for them. There is the 5.0, 5.1, and 5.2 is really a big jump off of the trend line. So we can see that there is some sort of boost exponential growth that is happening here that is not that was not happening before, and it's either the data or something else. We're not sure, but the closed weight models are still basically on trend towards the upper limits. You can see Fable is above the trend a bit here, and so is GLM, so we might have a bit of a off trend. Qwen 3.6 27B is right here, and we should have a Qwen 3.6 somewhere around here, or 27 billion parameter model, maybe somewhere here. Now, I do want to say that basically at Q4, if this trend line continues, we will have a Fable-class model that is open weights and runnable by basically technically consumer hardware, which, you know, is the very upper end of consumer hardware, basically half of a US car cost, or maybe a car cost in terms of a hardware. Now, let's go to some of the fun stuff, which is what I wanted to talk about, which is some of the benchmarks. These are some of the stuff that I basically run and try to keep for myself in terms of trying to remember how these models are doing. Now, if we look at some of the examples of output, this is like Qwen 3.6 27B MTP. Now, again, I do want to preface that this is running locally, so these are like quantized versions of models. They're not full versions. And when we talk about quantized versions, we're talking about that there is penalty inaccuracy. If we look at the divergence in how the quality gets impacted from the full model. So full models are like BF16 off the chart here at 100%. Now, for Onslaught, you can see that there is something called accuracy chart, and basically there you trade off the size of the model for its accuracy. I try to stay within like the Q4 and above accuracy range, so 97.5% accuracy. So it will make mistakes or have different outputs than the original model. Keep that in mind. I did also test some of the Q3 KXL because I have to for the 1 trillion parameter models. That is the largest that will fit on my hardware. So it is 92.5% accuracy rather than the 97. And anything below it, we are going down pretty hard to 82% accuracy. I did download GLM 5.2 at Q2 as well to test. So I will try to test that as well, probably in the next video, where I'm testing very quantized models of very large ones versus non-quantized models. You can also see the KL divergence, which is another way of testing the accuracy or how far away this model quantization is versus the original. So when I'm testing models locally, just keep in mind that none of them are the full model or full version. They are always part or crushed versions to simulate that they will be not, full accuracy. So if you want to look at full accuracy, you'd have to go API route or look at, people that use API non-local stuff. So for example, the Qwen 3.627B MTP version, which is very popular, this can actually do a good job of drawing like a capybara with matcha. Like they're still good models. They function, but they will have some errors. So you can't choose like the one output. You might have to generate a couple times. You can see here that the Pelican on a bike is pretty good, and also the PS4 controller is in the right places. We also have like the car SVG off Qwen 3.627B, and I just want to give you a heads up, like this is runnable on local hardware on one graphics card, basically, and this is the level that you currently get at the score of what was the score? Like 37.1. So this is a score you're getting currently, and it is a pretty good model. Now, if you go back to some of the other outputs, so this is like basically the model you have on local hardware, and this is where it is currently. And if we look at the trend line, you will get to about GLM 5.2 level by Q4 of 2026. Okay, so if we preface that, we have good stuff coming in the future. Now, let me show you some other outputs just to show you, like this is N2 Pro MLX 5-bit. This is 5-bit version of like a Qwen 3.5, which is some people did a lot of more training on Qwen 3.5, and they did improve the output of these models. So they look a bit different. Again, they're all quantized, so you're not going to have like full accuracy on these, but it is pretty good. You also have now the Mythos style. So this is actually Fable 5 Mythos output of a pelican riding a bike. And as you can see, that this is basically the best pelican riding a bike you can get with not only accuracy, but also style, where it is like actual really nice stylistic pelican that you could use in SVG. It's a vector graphic design and put like on a shirt or stylize it. So this is the kind of artwork you would be putting on an actual shirt, what this vector graphics is used for. And yeah, that is basically it for vector graphic tests, I believe. And after Fable, they will all be pretty much in the same range, not making any mistakes in the vector graphic space. So at this point, I might have to retire this benchmark and no longer use it. Also, the Fable 5, this is the car output. As you can see, it is very stylized. There is one mistake here with the wheel positioning. It is not at the very bottom, but honestly, that is one of the best outputs I've ever seen. So unfortunately, all these SVG outputs are getting kind of old, and I am trying to work with a couple of tests that basically are not seen. So in this case, I will say that this is like from a manga like called Soulland, and basically this is like not an accurate, obviously, representation of the man face demon spider, but I don't expect it to know what it is. Like it will know kind of what it is, but it doesn't have any of the reference to what it technically should look like. in the manga or probably anime. But it is a pretty good demonstration that this is not trained data that it has, and it has recreated it where you have pretty much a spider. It is moving on its own. It is pretty creepy. And so I'm trying to do a couple of tests where it's basically trying to figure out how these things would look like that it doesn't really have a good reference for. Now for NX N2 Pro, I'm trying not to cover it too much, but it was a pretty good model where like it can render stuff pretty well in 3D. But it was a bit like does loop a bit, so yeah, it depends. Your mileage may vary, obviously. And I also I got Fable to like recreate wishing simulators, so like it's fully wishable. Um, Basically, it recreated the wishing. Yeah, that's just my luck. Okay, so it recreated this banner system basically from a game called Genshin Impact, and pulled the assets and wrote it all in. So really, this was a test of understanding the layout and etc. And it was okay. It's not like the best polling simulator, but you can replicate that stuff. I also want to show you guys some of this Kimi 2.6 outputs for the spider, just in reference to what it is. So this is Kimi K2.6 IQ3 XS. And so this is the output that we are currently working with on a local model. And yeah, let's see. We got a bunch of like these games that I wrote with Kimi just to see how good it is. So this is a one-shot game, basically a Vampire Survivor game, and it's pretty good. It's actually kind of fun to run around this. So I don't know if this is actually a good test because Kimi did a really good job of kind of one-shotting this game, and probably I can't use this too much anymore as well. So I can't really use arcade games. I also have to show you that Kimi can also multi-shot like Pac-Man games, any arcade games. Unfortunately, I can't use those in benchmarks anymore either. This is a example of Minimax M3 for the Demon Spider. As you can see, there is a bit of, interesting mask orientation here, but it is functional. It looks like it. This is the best visual I have of like a Demon Spider kind of, because it is actually well lit. So Minimax did a really good job of having it well lit, and this is at Q8 KXL. I did try it at IQ4 again, and it is pretty similar. So it's not just the Q8 version that can do it. Some of the other tests from Minimax are, you can see here, this is like the panda, or sorry, capybara. Then there's like the pelican. It kind of nailed it. It's missing like a leg there. And this is the PS4 controller and car. I struggled a lot with the car actually. So yeah, this is Minimax M3. So now we're at the, I believe, 44 zone. So if you're comparing this to what Quant 27B was, this is like in this zone. And then I will show you guys, I'm not really testing voxels anymore SVGs anymore for GLM, because it kind of nailed all of them. This is again Minimax, the driving scene. So as you can see, it's pretty much also perfect. There's nothing I can do regarding this. It is very perfect. There is like some issue here, but if I open it full screen, it's not there. This is like something to do with the size of it right now in this gallery view. So that's fine. Now let's move on to some of the Kimi K2.7 outputs. Again, with the Demon Spider, you can see these are here. And basically I tried a couple of versions of it just to see how it works. So this is it in an environment. kind of like Spider. If you're familiar, then it has like these rings around it because it is in Soul Land, and they have like rings displaying its power, etc. It's probably not an accurate representation of the first one, but that's not the point. The point is that it can do this kind of like 3D scene, and it does have lighting and stuff. Then we have Kimi K2.7 Q3 KXL. It's just another test, just trying to see how it does with the different prompt. As you can see, it did kind of an interesting position here where like the head, it made the head kind of like look to the right. And I'm not sure if this is an error. It's probably an error in its logical orientation of the legs, but it did a pretty good job, even though it doesn't really know what a man face demon spider is. But I basically trying to put like a man face at the front and then legs here. So it's not super accurate in terms of what it looks like, but it is a pretty cool representation of how it is in voxel space. Now, I do also want to tell you guys how these models react using like local hardware. So Minimax is very good in terms of, it's very fast, and it's very good in terms of like doing very easy stuff. So very simple stuff it's really good at. If it does need to do like a lot of like thinking time, then it will go to like 95k tokens and it will produce a result. So that is the good part about Minimax M3. It will produce a result. It's just it will take a long time. Kimi has been really good these days with 2.7 reducing thinking time drastically. I believe it was a total of like 10,000 tokens on these voxel generations, where Minimax had to take like 60,000 tokens. So Kimi is very efficient in terms of how many reasoning tokens it's using. And don't worry, we're getting to GLM, so you can see them right there. This is my new, I guess, benchmark, which is that Pelican in Voxel 3D. So Kimi K2.7 created the Pelican. You can see that it's spinning the opposite way, and unfortunately it didn't really know how to fix that. It's kind of just going the wrong way. But it did do a good job. It didn't think too long. I think it was still within like 10,000, 20,000 token limit. So it was pretty efficient in terms of that. And this is at Q3, guys. It's not like the full Q4 model or anything. It is cut down pretty hard. And I would say Q3 is like the limit before it kind of goes off a cliff. And now that you saw that one, I will show you Minimax Pelican. So Minimax at IQ4. So now I'm using the Q4 versions of everything, and this was pretty quick. It was like 35 tokens a second. It was generating really quickly, and I think it did a really good job. Maybe a bit better than Kimi actually, but it did think a long time. I think it was about 50,000 tokens of thinking, and in terms of output, it was much longer, trying to think of all the rotation stuff. But as you can see, it is pretty good looking in terms of where they are in scores on the intelligence index. So Kimi and Minimax are within like the same kind of score. So let's continue onwards. Now, I did try GLM Q4 first with temperature of 0.1 because I did not know what I was going to get, and usually they say use temperature of 1, and in the past temperature of 1 was really bad, so I tried it with temperature of 0.1. So this is GLM 5.2, guys, at Q4, and it did a really good job. Like, this is definitely an improvement for me over like the Kimi or the Minimax in terms of aesthetic. Like, it looks like Minecraft, but somebody just like made it out of blocks. So this was pretty good. You can see like these blocks would be similar to the Minecraft trees and stuff. This is pretty good and it's very interesting, but the temperature is 0.1 to be more accurate. You can see that there's a bunch of Z fighting here. So that is an issue, and there's Z fighting in the seat. And that means it's just they drew in the same square the bike frame and the wheel. And so because it's in the same same space, they are fighting over which face is going to be on top. Okay, so as you can see, there's like camera movement, you can move around, there's a reset view, there's a speed, and you can see that the clouds move, I believe. I don't think there's a sun. But it is, oh yeah, there is a sun. And you can see there's a sun there moving around. So it is a really nice kind of scene here that GLM 5.2 created, which we're basically comparing it to this. So yeah, it's very good in terms of it. And this is the temperature one, guys. So this kind of blew me away, where this generation is temperature 1. Let me make it a bit bigger here for you guys. Okay, this is temperature 1 GLM Q4. So 97% accuracy is what's not full accurate. And the thing about this is it does actually have to fix some things. So when I output this in one shot, this wheel was a bit too big. So I said, you know, let's make it smaller because it's like hitting some of the frame here. And basically it did. So it kind of just fixed it. And the way it fixed it was it told me, go replace this and put it to like 1.7 instead of 2.5. And then it shrunk the wheel. Also like changed the orientation of it so it's above the ground here. But honestly, it mapped the leg to the rotation of this box here. And this is really cool. Like it is actually pedaling and it is flapping. And you can see that basically this is kind of like a game at this point. If you put obstacles, you can make this into a game pretty easily to jump. And it also has like a honk animation where it like shakes its head and stuff. So you can also change like the flapping speed and the speed of the how fast it pedals. There are some errors here. You can see like there's blocks that are attached to the ground instead of the grass. So yeah, obviously that's not perfect, but you can definitely fix it like one or two prompts. So it's not the worst case scenario. What else do we want to see? So this is kind of like blowing me away, where in terms of, hey, this pelican is actually looking good, and I could actually make this kind of like into a pelican game at this point and have it like drive around or have obstacles. So I'm kind of blown away at the design of it, going from the prior one. Okay, and my final one, I will just show you guys the demon spider that it created for Soulland here. Now, it's also not perfect, right? So you can see that it does have the rings here, 4 rings, and you can see its eyes and its teeth. But if you look at the back, you can kind of see through it, and it's because the blocks are actually not touching each other. So the blocks are not the right size. They have to be just a bit bigger so they touch each other, and the face, I don't think it's actually touching the spider. So all of this is an issue, and you can definitely fix it with like 1 or 2 prompts again. But that is basically what you get from one shot, depending on your seed. I would say it is a bit better than the other ones, but very slightly. It's not like super duper, like it's not a Mythos level generation. And again, you can see Mythos over here at the bottom. This was a Mythos level generation, and this was a 2-shot actually. It made it not as dense, and I said make it denser. So this is a Fable Mythos generation. Okay, so that's basically it. I am still working on one of these games here. I will see if I can launch it, and if not, it's not going to make it into the video and you won't see this, or if it works, it will come into the video. Okay, this is the final test for GLM 5.2, and I did use Pi code here because I needed to iterate a bit on it rather than having to recreate the full output. If you don't know if there's an error or if you want to edit code and you're chatting with it in the chat interface, it has to repopulate the full code again or tell you where to put the fix. Whereas if you're using an agentic harness like PyCode or Claude Code or OpenCode, you can just tell it there's an error or you want to change something or you want to make it look different, and it can edit the specific code related to that instead of generating the full code from zero. Now, what I asked it to do currently is make a Minecraft kind of game, but also a Vampire Hunter merge. So it's kind of like Minecraft plus Vampire Hunter, and it's kind of like a bullet time. Let's see what is happening here. So this is my first time playing it, but as you can see, we have the trees. We kind of have some of the mobs off screen, unfortunately. So, oh, I saw a mob there. We do have water, and it looks like we can go underwater, and we just kind of clip to that. We clip to the terrain. Oh, that is a bullet coming from somewhere. Oh, there is trees. There's a lot of trees. I will have to say that some of the... Oh, yeah, they're firing off screen at me. Some of the terrain is pretty good. I do like that there's a lot of trees. Some of the coloring isn't the best. I think it's a bit muted. But it is interesting that you can, you know, basically run around kind of like a Minecraft game here. Well, it's getting really dense. And let's just see what else he got here. See if it has like procedural generation zones. I believe it said it's procedurally generated. Oh, there's an enderman. So multi-shot. Okay. So piercing. Let's see what else we got. So it does look like there's a bit of a different biome here where there were trees there and then there are no trees here. And let's see what else, what other kind of biomes we have here. I'm just gonna quickly run through and see how far it pushed this game to. Okay, now we're back into the forest biome. And we have water again. It looks like the mobs are getting a bit harder. And yeah, honestly, like this is kind of a game I would actually play. Like probably ask it to make a bit more details on the trees and grass, but like a texture. Yeah, maybe some of the bullets. I wonder if we can like craft stuff. That would be good too. But yeah, let's see where else we get to. I just want to like experience it for a bit. Okay, so this is just all trees currently. And I can definitely tell it's procedurally generated. There's a boss. Oh, okay, so there's a boss level as well. Oh my goodness. Okay, so there is a boss level. I don't even know what that is. Some dragon. I don't know why it's backwards. Okay, I didn't survive that, or I lost the game. But as you can see, I have 151 kills, and there was a boss fight at the end here. We were running in one direction all the time, so it's procedurally generated. And there are still two problems: flat monotone terrain. There's some biome generation and lakes and stuff. So that is stuff you can actually fix in like future iterations of this game. But yeah, I just wanted to make a quick video, although it's probably not a quick video anymore. Just showing you guys what we have here in terms of local inference setups. And I know a lot of people run these models on cloud APIs, and here I'm just trying to make some videos regarding how they perform on the local hardware. So my final caveat is there's no full support yet for all of these local hosted models. Like let's say you get day one support via API, you don't really get day one support for local host stuff. So if I'm making a video, it's going to be towards like maybe a couple of weeks later that we can even get it working. Like GLM 5.2 was pretty good, but that's only because we had GLM 5 and 5.1 before that. And we're also not using the full attention that GLM has. So GLM 5.2 has like this 1 million context, and they also have like a flexible effort. So that works. The flexible effort works. I can use high or max settings. And they're also an index share, but we don't get the index share yet. So basically it is running. So GLM is running pretty heavily because there is really no indexer. And to put an indexer in, you have to use lighting attention from DeepSeek v3.2, which has not been merged into llama.cpp yet. So we are defaulting to this attention mechanism that is dense. And although it is a bit smarter, it's really hard to use it through anything more than 100K context, unfortunately. So you are like, I'm limited to 100K context on GLM 5.2. I cannot do 1 million no matter what. And there also is no MTP. So locally, we still don't have MTP support for it, and we're probably not going to have it for quite a while because we need like the index share plus to use this MTP support. Also on Minimax M3, we're not using their new attention mechanisms either because we're defaulting to the dense attention. There's the only caveat is that Kimi K2.7 has MLA, I believe, and it doesn't have the DeepSeek attention. So Kimi is running MLA, and it is pretty quick. Like it's 20 tokens per second, even at 1 trillion parameters, whereas GLM is like 15 and drops to like 10. Minimax also could be much faster, but it's about 25 tokens per second. So yeah, it's really unfortunate. But in terms of space, and running it locally on your own at home, I want to point out some things. So as you can see at the top here, I have downloaded Minimax IQ4 XS, which is still pretty good quality. It says it's 207 gigabytes in size, so that is the space you need, which is combination of your hard drive, your RAM, and your VRAM, so graphics card. So as long as you have all those three, that total to 207, you can technically run this on your computer. Now, the second you have a introduction of VRAM to CPU, you have an immediate slowdown. So if you do not have 207 gigabytes of VRAM, then obviously the slowest thing that you will have is going to be your CPU. So you will have to temper your expectations. So if you don't have the full 207 gigabytes of VRAM, or a bit more even, no matter how much VRAM you're going to get, as long as it's lower than 207, it's going to be based on the slowest part of your computer, which is going to be your CPU or CPU RAM. So basically just get one graphics card and a lot of RAM, and you can load this in. So if you have 192 gigs of RAM and you got like a graphics card, you can run Minimax M3 at Q4. For GLM 5.2 here, you can see it's 250 gigabytes in size at IQ2. And that you can run on basically also either two MacBook Maxes, 128 each, like, or two, probably three at this point, three machines, or you can have basically a computer that's 192 gigs of RAM plus plus a graphics card, and that also would work, or a couple of graphics cards. So this is really like on the high side of local inference, but technically it's doable. You can also have like multiple machines. You can have 2 or 3 machines that are connected through Ethernet, and this will also work. Yeah, it's really, that is what we kind of are aiming for locally. Unfortunately, we're going into the high territories of 500 to like 250 gigabytes for these top end machines. But if you remember my graph here, you will see that we're just behind in terms of having the top of the line. So Q1 2027, we will be expecting a 27 billion parameter model that is same as Fable 5. Okay, so don't get your hopes down, just keep your hopes up, and basically some of these models will be getting Fable 5 performance faster than others, and you're just a bit behind. If you have like a normal computer, you're literally only like 9 months behind to get Fable 5. So I think the future is bright, and you guys are gonna have a lot of fun in the future, and we're all gonna enjoy the next year or so. Okay, let me know what model you're using, and if you want to see that Q2 version of GLM. Okay, thank you. Have a good one.